Yesterday we started with chapter 10, lesson 5. That's talking about trigonometry and area. And we say that we learn how can we find the area of the regular polygons and the triangles using the trigonometry. We learned how can we find the area of a regular polygon using the sine or the cosine or the tan if I have a radius or if I have the side. And we stopped on this, got it here. For this one here, we say that if there's a tabletop has a shape of regular decagon with a radius of 9.5 inch. What is the area of the tabletop to the nearest square inch? Here now, we have a decagon. So I have 10 sides. A shape with 10 sides. With a radius is 9.5. What is the area of the tabletop? So here ask me to find the area. So as we learned before, that the area is half the apothem times the perimeter. And we have the radius. So we need the apothem and also we need the perimeter. So here now, imagine that we have a big decagon and I took the rectangle. Here, this is the vertices. This side, the pink one, is one from the sides from a decagon. Okay, I cannot draw it with 10 sides. So I want you to please to imagine that up here we have a 10 sides and only I focus on the yellow triangle. In this yellow triangle here, the radius is 9.5 and okay, and we have 10 sides, yes. So from this one here, from this yellow triangle, I need to find both of the apothem and the side. What we have to do, as we said yesterday, if we need to deal with the trigonometric functions, we need right triangle only. So let's look at this right triangle. So the R here is 9.5. Let's name now from this one we called it S. So half of it is S over 2. And also we named this line side with an apothem A. Then after that also, as we said, we need, if we want to deal with the trigonometric, we need an angles. From where we bring these angles? By finding the central angle here. Now, we said before that to find this angle, the central angle, we have just to divide 360 by, since it is decagon, so it's have 10 sides, so the central angle is 36. So the big one here is 36. Half of it will be 3. It will be 18. So now my triangle is ready. All of this previous data, I don't know it. I don't need it. I just need the triangle. Now look at this triangle here. As we know, as we said, we have to find the S and the A. So to find S as an example, we need, what did we need? Did we need tan or sine or cosine?
Cosine.
To find the side.
It's opposite and adjacent.
Opposite?
Opposite over hypotenuse.
No, Rose, it is opposite over hypotenuse. This is hypotenuse, the side, which is opposite. Okay, the side, the hypotenuse is the side that's opposite to the right triangle. So this is the hypotenuse. It is the side that is opposite to the right triangle. So to find S now, we have an opposite and we have a hypotenuse, which is the sine.
So it's sine.
Yeah. So sine 18 is the opposite, which is S over 2, over 9.5. Then sine 18 multiplied by 9.5 is equal S over 2. So say approximately it is 2.9 equal to S over 2. So S, it will be this number, so it will be 5 over 8. This is the length of the side. So the opposite here, to find it, for this angle, it will be an adjacent. So which function should we use? If we have an adjacent and the hypotenuse?
Tan.
Adjacent,
No,
and hypotenuse.
Adjacent and hypotenuse, cosine.
Cosine, thank you. So cosine 18 is A over 9.5. Then cosine 18.
Teacher, can I use tan since I find 5 points?
Yes, oh, yes, also yes. It's equal, so it will be 9, approximately 9.0 something, so say it is 9. Now, okay. So we found now A and we found S. So by now we can find the area of the polygon. So now after that, so let's have an A here, the value of A here, and the value of S here. Then after that, let's delete here. So now we need to find the area. So we know we found A, which is 9. We found P. We need now to find P. As we said, P is n times S. S is 5.8 times n. Since it is decagon, so it has 10 shapes, 10 sides. So the perimeter here is 58. Then by multiplying 9 times 58 divided by 2, you will get that the area is 261 square inch. Is it clear now?
Yes.
5.8 is the half of the length. So we should add 5.8 by 5.8.
No, I suppose that it is S over 2. But if you wrote it as X, you have to multiply it by 2.
Oh, okay.
Okay, I write it as S over 2. Okay?
Yes, okay.
Okay. Now, then we were gonna now to learn how can we find the area of the triangle. Now, by now, we know the two ways to find the area of the triangle. The first way, that all of us know, if we have three sides, so the area of the triangle will be half the base times the height. This is a way to find the area of the triangle if we have three sides. And sometimes if we have an apotheme with length of the side, so we will say now the here it's half AP. This is another way, but if we have an apotheme, not the height. Here, if we have the three sides known, or we can say it's if we have three sides, so I can find the height, and after I find the height, I can use it to find the area. Today now we learn a third way how to find the area of the triangle, but now here by using the SAS, or that if you have two sides and an included angle between them, like this triangle, like this one as an example here. If you have this one here, and for this one, I will repeat it here 2 times. Before that, we found the height and we know the base. This so we have half BH. Today now, if you have the length of this base, name it as of this side, name it as A, and we have the length of this side, which is B, and we have an included angle between them, which is C. So our area, it will be half AB sine C. Here it is, this is AB sine C. Okay, this is AB sine C. I think this is not chapter, it's another chapter. Okay, so let's name it as AB sine C. So this is a third way, or the you can see the second way to find the area of the triangle. If we have the sides only, you needed to find half BH, and if you have two sides and the angle between them, we will use the half A times B sine C. Let's see here now how. Suppose that you want to find the area of the triangle. Now look at this triangle here. We have a triangle ABC, and all of us know that to find the area, we will use the formula that says A is half BH. So here now, let's have this triangle here. As an example, we have here this triangle. Now let's name this one. Now, all of us know that if we have this angle A, so the opposite of the side that's opposite with an angle A in capital letter, I will write it with A but small letter. And if we name this vertex here with B capital letter, so this is angles. Okay, I will move it down. And since here this angle is B, so the opposite side of it will be B small, and the name of this vertex is C, so its opposite angle it will be C small. Now, imagine now we have to find, or we need to find the area of this triangle. As we know before, we must need the length of the base and the length of the altitude or the height that is perpendicular on the base, with which we name it with h. So all of us know now that the area of the triangle is half the base times the height. Now, but here we don't know the value of the height. Let's find now the height as. Now, if you have look at this triangle, is this triangle a right triangle?
Yes.
Yes. So let's see now that in this triangle here, if we have, or if you need to find h, okay, I need to find h. So can I say now, look at here, that sine angle A, okay, sine, let's remove these lines here. Now, sine angle, oh my God. Sorry, sine angle A is an opposite, which is h, over the hypotenuse, which is c. Is it right?
Yeah.
Here, this is a way to find h. Then, so I will say now that h is c sine A. Is it right? By cross product.
Yeah, it's diagonal.
C sine A. So come back now to my formula here. In this formula, we state that area is half BH. So by substituting now, instead of H, I will substitute now with this one that I found it before. So H here is C sine A. So I will substitute now H with C sine A. So I will get now my new formula. This new formula helps me to find the area of the triangle if we have two sides and the included angle between them. Like, so the new formula is half BC sine A. That's mean if I have this triangle, this is B and this is C. Okay, if this is B and this is C, A, it must be included between them. Don't use this angle or this angle. Only the angle that is included between them. So you will say half the length of the B times the length of the C times sine of the angle or the included angle between them.
So we will take only for the half for this system?
Sorry?
Only for the half, not the base.
No, don't need the height now. Only I need you to find B, multiply B times C times the sine of the angle between them. If you have the height, you will use half BH. If you don't have the height, you will use this formula. So now the area of the triangle is half the product of the length of the two sides, in the sine of the included angle. So the angle, the area of the triangle ABC is sine B this. Sine B C sine A. This is a way. Another way, you can say half A B, and sine which angle? What is the included angle between A and B?
It's C.
C, thank you. If you have, as an example, half AC sine the included angle between A and C is B, thank you. To know it correctly, here we have letters A, B, C. So if we have A and B, the missing is C. If you have A and C, the missing is B. Let's now have examples here. Now, how can we find the area of this triangle here? Now look at this triangle. The first thing that you have to check that these two sides has an included angle. An included angles. If these two sides didn't have an included angle, I cannot use this formula. Now look at these two sides. Did they have an included angle?
Yes, it's 84.
Sorry,
48.
48, yes. But yeah, sorry. Okay. First step, if you want to use this formula, which is the area, where the area is half the two sides times the included angle, we must first check if the angle is included between the two sides. If it's included, I can find the area. But if it's not included, as an example, if you have this triangle here, I give you this is 3, and this is 4, and this is 30, as an example. Now, can you find the area of this triangle?
Yeah.
No. Why? Because I'm saying using this formula. I know, yes, you find it by half BH. But using this formula, no, because I told you that we must have the side and another side and the included angle between them. Now look at this angle. Is it included between them?
No.
No, so I cannot use this formula. Is it clear now?
Yes, teacher.
Okay. Now, so the area here is half. Now, what is the first side?
21.
21. The second side? 12. Now, what is the angle, the included angle between them? Sine?
48.
48. Then, sine 48 multiplied by 12 multiplied by 81 divided by 2. So the area now is 93.6 centimeter squared. Is it clear?
Yes, teacher.
Okay. Now let's do this one now here. What is the area of the triangle? Look at this triangle here. What is the area of it? Half.
It's half 10 multiplied by 16 sine 34.
10 times 16 sine 34. This is the first side. This is the second side. And 34 is an included angle. Then, so sine 34 times 10 times 16 divided by 2 is 44.7 square inch. This is the area of the triangle. Now, before solving this one, I want you please to look at this example here. What is the area of the triangle shown on the right? This is number 28 in your book. Look at this triangle here. I told you that if I need to find the area of the triangle, we need two sides. Yes, they are given 8 and 10. And I saw an angle that's included between them. What is the measure of the angle that is included between them? Is it 79 or 53 or another one?
Another one.
Another one. Thank you. I need to find the angle that's included between them. How can we find it?
The third angle of a triangle theorem.
Yeah, that's all of us know that the summation of the angles in the triangle is 180. So 53 plus 79 plus angle x as an example is equal to 180. Then let's add 53 plus 79 minus 180. So x now it will be 48. Then this x, I use the sine of it because it's an included angle. Then I can find now the area of the triangle. Is it right now?
Yeah.
So sine 48 times 80 divided by 2 is 29.7 centimeter square. This is an area of the triangle. Now look at this question here. PQRST is a regular pentagon with a center O and a radius 10 inch. So the radius here is 10. Where's the radius to be? It has to be here.
So what was the last answer? For 58?
29.7. So here now the radius. Find each measure. If necessary, round your answers to the nearest 10. Now let's start with A. A now. What is the measure of the angle POQ? Yes, Habiba.
Yes, teacher.
Yes, the measurement of the angle POQ. This angle here. How can you find it?
The measurement of POQ is 180.
No. How can we find the central angle? Yes, Rose.
To find the measure of the angles, we will need 360 because all the angles equal 360.
Thank you. Thank you.
So,
You divide 360 by?
by 5 because the number of the sides is 5.
Thank you so much, Rose. Here we have to divide the measurement of the angles by how many sides we have. Here we have a pentagon, so we have 5 sides. So the measurement of the angle POQ is 72 degrees. Now B. Measurement of an angle POX. Yes, Lama. Yes, Ragad. POX.
Because POX is half of measurement of angle POQ, so it's 72 over 2.
Thank you. It is 72 over 2, which is 36. This is the angle of P, measurement of the angle POX. Now see. OX. Where's OX? height. How to find the height now? I need to find the height of the triangle. Here, this is my triangle. Here is.
Can I?
Yes, Samson. Here is O. Here is 10, and what's all about? Okay, and here it will be 36 now. So
We
what
can use the cosine trigonometric ratio. We can say cosine of 36 is equal to x over 10. And then we solve for x.
Yes, it's equal OX over 10. Then, so 10 for cosine 36 times 10. So it will be now. So OX now, where's this?
Approximately 5 square root of 3. Like it's going to be greater, but approximately 5 square root of 3.
It's 8. So OX now supposed to be 8. This is the value of OX. Now then, PQ. Where's PQ? The length of the side. I have to use what now? Sine, is it right?
Yeah.
Sine,
Yeah.
sine 36 over the hypotenuse 10 is equal x over 2. Oh, PQ. Oh, wait, what do I have to do here? No.
Px equals sine 36 over 10.
Sine 36 is equal to x over 2 divided by 10. So 10 times, sine, sorry, 36 times 10 is equal x over 2 by 2. So x now, PQ now is 11.7. This is not x, this is PQ. Now for E, what is the parameter of the triangle PQRST?
It's S times N.
N times
Thank you.
S.
So the parameter here is N times S. How many sides we have?
5.
5. What is the length of each side?
11.7.
11.7. Thank you. So times 5. So the answer here is 58 point something. What is the unit? What is the unit?
Inches.
Inch. Yes. Now the last one here, to find the area. How can we find the area?
Half the upper thumb times
A times B.
Then the parameter here is 58. A, we found it as, where's A? Where's A? It was 8 times half. So the answer here, it will be
468.
35 point something.
I got
235 inch squared. I think now after a few seconds,